Welcome you are to today's lecture. Today we discuss the root locus. For this we consider a very simple unit feedback system here, and this is the controller. Actually, this is a gain controller because it didn't have any dynamics. In dynamics, we means that there's no pole and zero in it, so this is just a constant number. So we are looking how we can design this gain controller, and this is our open loop transfer function, and this is a unity feedback. So if I have to write the closed loop transfer function here, so it's the ratio of output to the input in Laplace domain, so it becomes kg of s divided by 1 plus kg of s. So then we define the characteristic equation. You know that characteristic equation is the denominator. When we put this equal to 0, we get poles of the system. Okay, now we are very much concerned with this root and locus, so we are concerned here for this root. So if we solve this equation, we get the values of s. Those are known as roots, and those are in control system domain we call it poles. And we want to look at the locus. Locus means that if we vary the value of k, how the pole location moves from open loop to closed loops. Okay, so actually we know that if we rewrite this equation and we write it in kg of s equal to -1, so because this is a complex number, so we know that we can write the complex number in terms of magnitude. If we take the magnitude of this becomes kg of s equal to 1. This is equation number 1, and from this magnitude we easily calculate the value of k. Okay, that satisfies the condition. Now the next condition that needs to be satisfied, because this equation gives us the value of the gain that we want to find, or value of the k, okay, where this value exists and how we get it. The second condition is the phase. If you remember, in complex number there are two things. One is the gain and other is the phase. Now here, if I take the for same equation, if I take the phase of this becomes, -1. If I plot in the Cartesian product, sorry, Cartesian coordinates, so this is 1 and this is -1. If I try to start from here, this is 0 degree, and come here it is 90, then this is 180. Or in clockwise direction, this is equal to -180. So I can make different rotations, but I will get the same number here. So we can represent this -1 in terms of angle as angle of kg of s equal to 2i plus 1, 180 degree. Okay, so because it can represent 180 minus 80 simultaneously, also revolution after 360 degree we get same -1. So that's why we have here I, that is either 0 plus -1 and so on. Okay, so if this condition holds, we use this equation to calculate the gain of the controller. So this is the basic idea on which this root locus exists. Now to further make it clarify it further, in previous case we just assume a unit feedback, but you can have if dynamics here in the feedbacks. Again, you have the same characteristic equation, same magnitude equation and same phase equation, only here the difference is kg of s. Now the main idea here is we have to look for these kg of s and try to solve the root locus based on this equation. Now let's look at an example to clarify us. Now this example is where we have kg of s given us in terms of k divided by s into s plus 1. Now here, if you look at here, this is the denominator. If I put equal to 0 where I have poles, I can represent poles by a cross here on the s plane. So this is my s plane. So let me write here, this is my s plane. Okay, now for this s plane I have pole at the origin and pole at the -10. Okay, now there's no 0 here because numerator has no dynamics here. Now the idea is how I plot root locus here. So first step is to if I wrote here step number 1, is actually draw poles and zeros on S-plane. So this is the first step that I already perform. I just plot poles and zeros. Now step number 2 is that step number 2 says that at poles k is equal to the value of k is start from okay, k is 0 at zeros, k equal to infinity. Okay, so it can be plus minus infinity, so better to write both plus minus infinity. Okay, so this is the second step that we know that. So from here we can know that if, for example, this is the example here, we have it's not clear, so it's better to use on this one. Now step number 3, how we draw. So on real axis, on S-plane, so for real axis means that we are talking about this axis. Okay, this is the real axis and we normally represent in a sigma. So this is j omega axis. Okay, so this is the S-plane. Now for real axis, how we can plot the root locus. So the main idea is that this is my right hand side and this is my left hand side. So we have to look at our right hand side. If number of poles is odd, then this means that root locus exists. Now I am here at this location and I am looking in this direction. Do I find any poles and zeros? No, because number of poles and plus zeros is 0. So 0 is even. So this means that there's no root locus exist at this location. So this means that root locus exists on right side right side of odd number of poles and zeros. So if the number is odd, then this means that root locus exists on the right side, otherwise it's not exist on the right side. This is only true for real axis. Okay, so we are looking for real axis. So on the right side, if the number is odd, then root locus exists. So in this example, if I redraw here, so here is the pole, here is the pole at -10 and 0. So I just continue this example. So if I am here, so on the right side the pole is actually even 0, so there's no root locus exist. But when I come here and look in this direction, okay, I'm looking in this direction, so in this direction when I look, there's one pole exists. So this means that root locus exists here. Okay, because the right side of has the odd number of poles are 0, so that's why root locus exists. It will exist till the next pole. When next pole came, I am here and I will look again in this direction. Now pole number is 2, so this means that there's no root locus exists on the left side of this even number of poles. So the main idea is I have to look in this direction. If we have an odd number here, then this means that root exists. If number is even, then root locus will not exist. Okay, so till we get the next. So this is the basic idea from where we can have root locus. So the next thing we remember from here is that the case start from here. So this means that a root locus will start from the poles. Okay, so on real axis root locus will start from the poles, and we know that it ends at the zeros. So because root locus will need to be end, but here we didn't find any zeros. So where are those zeros? Those zeros exist at the infinity. So how we find that in which direction in infinity these poles exist? So this is our step number 3. Step number 4. Okay, now step number 4 says that I am looking your 8.4 for sketching. Now it says that number of branches. So the number of branches of the root locus equal the number of closed loop poles. Okay, now how many branches here? So number of branches equal to number of closed loop poles. Okay, now here we have 2 branches, so we don't know how these branches look like. So now we move to next part. Next part says that next part is symmetry. Symmetry says that this is also step number 5 is that root locus is symmetric along the real axis. Okay, so these what we learned till now, that if we have a number of poles and zeros, we can easily draw it on the real axis. Okay, now it is not complete still. Okay, now to go for the branches, we need know the step number 6, that is number of asymptotes. Okay, so asymptotes are those which are goes to the infinity, because if there are only 2 poles here, but we say that actually the number of branches is equal to number of closed loop poles. But we also know that if there are 2 poles, there must be 2 zeros, but those zeros are not present in the closed loop transfer function. They must be at the infinity. So in which direction in the infinity? Here, in this direction, either direction can be possible. To find those direction, we need some more information. So these are asymptotes. So we have asymptotes. So asymptotes help us to know these values where they go to the infinity. Okay, so these asymptotes, they have different properties, and if I write here, first one is number of asymptotes. Let me write on the new page here. First one is asymptotes. First one is number of asymptotes. Sorry. So number of asymptotes is actually equal to n minus m magnitude. So what is n? N is number of poles, m is number of zeros. So in our example, we have this situation. Here number of n is equal to 2 and m is equal to 0. So number of asymptotes is equal to 2. So we have two branches that goes to infinity. Asymptote means that those branches that goes to infinity. Okay. Now first thing is number of asymptotes. Second thing is how we identify in which direction these asymptotes will go. So location of asymptotes. Now location of asymptotes. Location is represented by sigma, that is equal to summation of finite poles minus summation of finite zeros whole divided by number of finite poles minus number of finite zeros. So this is the basic equation, where we have finite poles minus finite zeros divided by finite poles, number of finite poles minus number of finite zeros. So in our example, where we have how many poles? 2 poles. Now for this example, if I want to find the sigma, so sigma becomes, what is the location of pole? Is 0, second is minus 10. So summation means that 0 minus 10 minus, where is the 0? Is there any finite 0? No, 0, divided by, because there is no 0, I put 0 here for this formula. Now number of poles, finite poles, how many? 1, 2. So you have 2 minus number of zeros, there is no 0, so 0. So the location of the asymptotes becomes minus 10 divided by 2, that becomes minus 5. So we come to know that this is the location of the asymptotes, where asymptotes goes to infinity, and this is the value of sigma, that is equal to minus 5. So it's very easy. We have to find the infinite branches, where those branches that goes to infinity, or in other words, we want to find the direction in which we have zeros that at the infinity. Okay, so this is the one, we know the location. Now the next is the angle at which they will go to the infinity. So next one is the angle of asymptotes. Now these angles we represent this by a theta. Okay, now this theta is equal to 2i plus 1 times pi. Okay, pi is 180 divided by n minus n. So you know what is n and what is n. Okay, now here because we can have different values of I, and I is start from 0, plus minus 1, plus minus 2, and so on. Okay. Now for that case, for in our example, this is theta I. Okay, for our example, so we have there are 2 i's. Okay, because we have this goes to the number is goes to up to n minus m minus 1. Okay, this goes up to n minus m minus 1. So there are two angles. So theta 1 is equal to 2 times 0 plus 1 divided by 2 times 180 pi. Okay, so it becomes 0, so it becomes 90 degree or pi by 2. Okay, similarly for theta 2 we have to put 2 into 1 plus 1 pi divided by 2. This is equal to 3 pi by 2, or in other words this is equal to 270 degree. So these two angles we calculate for this asymptote. So this means that at this location we have to draw a 90 degree. When I do that, this is my 90 degree, okay, and this is 90 degree. All right, so what about 270? So this is 270. If I draw here, this becomes 270 degree. So this is the asymptote location that this branch will start from here and follow the asymptotes and goes to infinity in this direction. Similarly, this branch starts from here and comes down to infinity in this direction. Okay, now let me redraw it on new page. Now on this page again I do the same mini example here and here. So this is minus 10, this is 0, so this is my asymptote. Okay, so one branch start from here, it goes in this direction, other branch start from here, it goes in other direction. So this is my root locus. Okay, so here is the 0 at the infinity and here is the other 0 at the infinity. So this is the root locus that I plot for this example. So this is what we need. Now till now we can, after this we are able to draw the what you say, free sketching without accurately calculating the point. So another thing is that we must know that this is step number what was step last one was 6. Now step number 7, remember this, that root locus start from poles and add at 0. So this is very, very important. Okay, now after this we can plot by a freehand, we can sketch any type of root locus. How we can do that? For example, first step is to have some poles, right? So for example, you have poles here, you have 2 poles at the origin, you have 0 here, you have another pole here. Now this is a bit look a bit complex. All right, now we want to do it free sketching here. How we can do it? Now one thing in calculating the angle that we discuss in case of asymptotes, for calculating angles we can consider we consider a ball here. Okay, and these are balls. So if I have two branches or asymptotes, so I need to cut into 2 halves. So I can make either half in this direction or half in that direction. So there are 2 possibilities that I can cut this. For example, this is a pizza and I can cut either in vertical or in horizontal direction. Now which direction I have to put here? So this will tell me the root location on the real axis. If there's a location on the real axis that goes to infinity, then I have to choose this one for asymptotes. So what this means? This means that there are angles that is 0 and 180 degree. Okay, so for this location I choose, because there's no infinity at the origin, so I choose this, and this angle give me 90 degree, and this is 270 degrees. So this is the way we can cut it. Okay, now I will show you further and try to tell you. For example, this is my 10 here. Okay, so this is 0 as you know that, and this assume is -5, and assume this is -20. Okay, now this is the pole plot, and I want to draw the or sketch the root locus. How I can do it? I will start from here and look here. Is there any poles at 0? No, there's 0. So this means that this part is not contain any root locus. When I move here, I see only one pole, so this means that this is odd number, and we have root location on the left side of this odd number. So this means that root locus will start from here and still here. Now when I look here, I will move to this and I count 1 2 3, again odd number. So this means that root locus will also exist here, and we know that always root locus start from pole and end at 0. So that's why direction is starting here and ending here. This direction is also going in this direction. Okay, you can't finish root locus on the pole. You always need to finish on the zeros. Okay, now when I move here, I count again 1 2 3 4. So there's no root locus. When I move here, there's a root locus, and this will start here and goes to infinity. Okay, now the next thing for free sketching I must need to calculate is n. How many poles we have? 1 2 3 4. So there are 4 poles, so n is 4. How many zeros we have? We have only 1 0. So if I do n minus m, so answer is 3. Now this means that I need 3 branches. So how I can make 3 branches without doing any calculation? So I make a circle here, I make a pizza, and I need to cut it into 3 possible pieces. So one possibility is like this. Okay, so other possibility is like that. Okay, another possibility is like that. These are the possibilities that I can cut it, but which I have to use? I have to use this because this branch is going to infinity here. This is going to the infinity, so I choose this. So this means that if I have to look here, if I plot, if I look at angle, this angle is actually this angle is 120 degree. This angle is again 120 degree. This angle is again 120 degree. So if I add all these angles, this becomes 360 degrees. So this is the way we can cut down. So or if I look at, this is 60 degree and this is also 60 degree. So this means that I have to find the point where I have to draw the asymptote. So how can I find the point? I know that I have to write the values of real values of pole, that is -20 plus, but it is minus again, minus sorry 0 plus 0. Okay, then plus 10. Then I have to put the minus sign and do for the 0. So 0 is -5 divided by n minus, that is 3. When I solve this, sigma becomes -10 plus 5 divided by 3, and it becomes -5 by 3. And when I do a little mathematical, it becomes -1.676. okay, approximately. All right, so this is the value. So we have something here. This is the sigma value. All right, now at this point I have to draw the asymptotes in this direction, and this is the third asymptote. Okay, now this means that because we have this pole, and this pole need to be go branches, because the one branch is coming in this direction, other is this. So this means that one branch is finished to 0 here. There are 2 branches that need to go in this direction. So this means that these branches will continue going in this direction like this. Okay, so like this. So this is the way these will come towards 0 and then go this way. So this is the way we can easily plot the root locus. So this is a freehand sketching. We will do next examples in next video. I'm stop here. Thank you.